Hi, this is King of Review. Kim ran a 15-kilometer marathon course yesterday. At first, he ran at the speed of 6 kilometers per hour. Then, later, he walked at the speed of 4 kilometers per hour. It took him 3 hours and 40 minutes to finish the course. How many kilometers did he run? So what we want to do is set up two equations that represent this situation. And before we do that, we need to say what our variables are going to stand for. So we're going to let x equal the kilometers that Kim ran. So this is the distance that he ran. And let's let y equal the kilometers that Kim walked. So the distance that he walked. So now we've set up our variables. Now we can make a couple of equations. So let's look at this first sentence. He ran a course that was 15 kilometers. So the total distance of the course was 15 kilometers. So if the total distance is equal to 15, we know that this consists of the distance that he ran plus the distance that he walked. So the distance that he ran was x, and the distance that he walked was y. So x plus y, those two distances added together give us a total of 15 kilometers. So there's our first equation. X plus y equals 15. Now let's consider the different speeds. Well, he ran at a speed of 6 kilometers per hour, and then he walked at a speed of 4 kilometers per hour. And the total time that it took him was 3 hours and 40 minutes. So let's first rewrite 3 hours and 40 minutes as a fraction. So if we have 3 hours and 40 minutes, so 40 out of a total of 60 minutes, this is 3 and 4/6, or 3 and 2/3 if we reduce that. And let's just put this as an improper fraction. So 3 times 3 is 9. Plus the 2 gives us 11 over 3. So 11 over 3 represents the total number of hours that he took to finish the race. So we have 11 over 3. So the race consisted of the time that it took him to run, and then the time that it took him to walk. So how can we calculate the time that it took him to run? Well, we know that distance equals rate times time. So we can use this formula if we want to figure out how long he ran for. If he ran at the speed of 6 kilometers per hour, we can write this as, well, t, time, is equal to distance over rate. So the distance he ran over his rate. So that would be x over 6, because the rate that he ran was 6 kilometers per hour. So x over 6, another way of writing that is 1/6 times x. And now let's do the same thing for the time that he spent walking the course. Well, time equals distance over rate. So the distance that he walked, we've said that that's equal to y, and the rate that he walked, well, that's 4 kilometers per hour, so y over 4. And another way of writing that is 1/4 times y. So there's our second equation. 1/6 times x plus 1/4 times y equals 11 over 3. So we have our system of equations here. What we want to do is solve for x and y. So one method for solving for x and y here is to use something called Cramer's rule. Cramer's rule uses determinants to solve a system of linear equations. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use Cramer's rule to solve for x and y. And you can see that our system here is set up in this same format. So what is Cramer's rule? Well, Cramer's rule states that we can solve for x if we take the determinant of the x matrix and divide it by the determinant of the coefficient matrix. And likewise, to solve for y, we take the determinant of the y matrix and divide by the determinant of the coefficient matrix. So this is how we use Cramer's rule to solve for x and y. Now let's figure out what our three matrices are. Well, we have a coefficient matrix, and the entries in this matrix are going to be the coefficients of the x and y terms. So A, B, C, and D. The x matrix, the entries in this, we'll start with E and F, and E and F you can see here are the constants of the two linear equations, and then we have B and D. And then Y, the Y matrix, this is equal to A, C, E, F. So this is the setup for the three matrices. So let's fill in our specific values for the entries. Let's look at the coefficients. Well, we have a coefficient here of 1, another coefficient of 1, then we have 1/6 and 1/4. So 1, 1, 1/6, and 1/4. Now let's set up our x matrix. Well, E and F are the constants, so that's 15 and 11 over 3. So we have 15 and 11 over 3 here. And then B and D, so 1 and 1/4. And then our y matrix. That's A and C, so 1 and 1/6. And then E and F, 15 and 11 over 3. So now we've set up our three matrices, but if you remember over here, using Cramer's rule, if we want to solve for x and y, we need to figure out what the determinants are of these matrices. What is a determinant? Well, a determinant is a real number that's associated with a square matrix. So let's say we have a matrix with entries A, B, C, D. To figure out the determinant, we're going to take the product of the main diagonal, AD, and subtract the product of the entries in the other diagonal, CB. AD minus CB. This gives us the determinant. Now let's figure out our determinants. Let's start with the coefficient matrix determinant. We're going to take the product of the main diagonal, so 1 times 1/4, and we're going to subtract the product of the entries in the other diagonal, so 1/6 times 1. So this is how we set this up. 1 times 1/4 minus 1/6 times 1. And when you work this out, this is equal to 1 over 12. So that's the determinant of the coefficient matrix. So now let's look at our x matrix. We'll take the product of the entries in this main diagonal, so 15 times 1/4, and then we subtract the product of the entries in the other diagonal, so 11 over 3 times 1. So we have 15 times 1/4 minus 11 over 3 times 1, and when we work this out, this equals 1/12. Now let's figure out what the y matrix is. We'll take the product of the main diagonal, so 1 times 11 over 3, and subtract the entries, or the product of the entries in the other diagonal, so 1/6 and 15. So we have 1 times 11 over 3 minus 1/6 times 15, and when we work this out, we get 14 over 12. So now we have our three determinants, and we can fill that in here. So x is equal to the determinant of the x matrix, that's this number here, 1/12, divided by the determinant of the coefficient matrix. Well, that's equal to 1/12. So we have 1/12 divided by 1/12, and that's 1. So we know that x equals 1. Now, what did x represent again? Well, let's look back up here. X is the distance that he ran. So 1 kilometer was the distance that he ran. And let's figure out what y is. The determinant of the y matrix. So we have 14 over 12. And this is divided by the determinant of the coefficient matrix. That was 1 over 12. So when we work this out, we have 14 divided by 12 over 1 over 12, and this equals 14. So y equals 14. And what did y represent? Well, that was the distance he walked. So 14 kilometers was what he walked. The question asks for how many kilometers did he run? And we figured that out here. It's 1 kilometer. Thanks for watching.